Alternating current versus direct current. In this video, we're looking at basic forms of electricity, alternating and direct current, and how it applies to e-bike systems. Why it matters, to understand how electricity changes throughout the e-bike system. And there's a few key concepts that are used later in videos. Prerequisite VODs, just the videos on voltage, current, and resistance, and watts, amp hours, and watt hours. Alternating current. Universal symbol is AC, or a squiggly line. It's driven by a switching positive and negative voltage difference. Imagine if the cars or the electrons were to be vibrating forwards and backwards very quickly. The vibration speed is measured in hertz, which is cycles per second. Most cases, it's between 50 and 60 if you're looking at power from household appliances or mainline transmission. On e-bikes, you'll find alternating current inside the motors and also from the charger. Direct current. Universal symbol DC or a dash with 3 smaller dashes below it. Think of it like cars all driving one way down a highway where there's a net velocity drift or flow of traffic. It's driven by a continuous positive and negative voltage difference. So that's kind of the eagerness of the drivers to get from A to B. You'll see direct currents most commonly in things like LED lights, smartphones, batteries, and many smaller e-bike components, including the e-bike battery itself. Looking at an e-bike example, we've got a sine wave here to represent alternating current, and then we've got the symbols for direct current, and then a 3-phase sine wave, which means there's alternating current times 3 overlapping for the motor. So let's go through this process. The charger plugs into the wall, takes AC energy from the wall outlet and converts it into DC energy. That energy then gets stored into the battery, and then the battery uses that energy to power the components on board the e-bike. So we're talking sensors, display, inputs, the controller itself, which then uses that DC energy and converts it to 3-phase AC for the motor. Now you might notice that there's arrows pointing backwards here. So what happens with some motors, which we'll cover more in later videos, they have the ability to regenerative brake. Imagine a truck that's engine braking. So engine braking, it's like when a truck makes a loud noise from its engine and it's slowing down just using the resistance from the engine itself. Regenerative braking on e-bikes, it's kind of the same thing. The motor acts in reverse to slow the e-bike down on some motors, and the energy goes back into the controller, which then turns that 3-phase AC back into DC, which then gets stored in the battery. And that's how you get regenerative braking. So that pretty much sums up the journey of how electricity changes throughout the e-bike. So let's have a look at a real life example. Here we have a charger. This charger has an input, number 1, of 100 to 240 volts at 50 to 60 hertz, and it is drawing 2 amps. This voltage of 100 to 240 volts is the acceptable voltage that you'll find across most places in the world with their wall outlets at 50 to 60 hertz. The 2 amps as well is a relatively low amount of current that is being drawn. Next we have the output, which is 42 volts direct current at 1.7 amps. This is the amount of energy that gets transferred from the charger to the e-bike. And lastly, on the charger at a glance, number 3, we've got the wattage and voltage output. And so 42 volts at 1.7 amps is 71.4, or here they've shortened it to 71 watts. Now we'll go into more detail on charger specifics in a later video. Click here to watch the next video. It is the best free thing you can do to tell YouTube to support the channel. Otherwise, if you want to do more, check out the links in the description. Thanks for watching.